So, problem number 11 from laws of motion. The question is a block of metal of mass 2 kg on a horizontal table is attached to a mass of 0.45 kg by a light string passing over a frictionless pulley at the edge of the table. The block is subjected to a horizontal force by allowing the 0.45 kg mass to fall. The coefficient of sliding friction between the block and table is 0.2. Calculate the initial acceleration. B. Tension in the string. C. The distance the block would continue to move if after 2 seconds of motion the string should break. Then here it is the diagram. So according to the question, here this 2 kg mass is on a horizontal table. It is a table. Okay, and this 2 kg is attached by one end of the string is attached to this 2 kg and another end is attached to the m1, that is 0.5 kg, with supporting a pulley, frictionless pulley. There is no friction here. Okay, so then while it is moving on the sun, we are applying a horizontal force on this direction. So then this 2 kg of mass is moving on the table towards positive x direction, means in this direction. So if it is moving in this direction, there is some acceleration produced here, and that acceleration is nothing but here initial acceleration. So if we write the data, that is m1 is equal to 0.45 kg, which is downward, and m2 that is equal to 2 kg, it is on the table, and coefficient of sliding friction, that is mu k, is also given, that is 0.2. Then now first find out the initial acceleration. So regarding the question A, that is initial acceleration. So for that we have one formula, that is m1 minus mu m2 by m1 plus m2. It is from Atwood machine. Already we have done one problem based on this question. Sorry, based on this formula. Then that is equal to, what is the m1? 0.45 minus mu is 0.2 and m2 is 2 kg by 0.45 plus 2 kg into 9.8, and it is equal to, so 0.2. After calculation of this all we are getting 0.2 meters per second square. This is initial acceleration of the block m2. Okay, this is m2 and this is m1. Then question B. That question B is tension in string. Tension in the string. Tension means we have to now find out this tension force. So this is subjected to be horizontal force. We are applying a force in this direction, so it is moving. This block is moving in this direction. Then according to the Newton's second law of motion, this tension force is larger than this friction force. Then only it is moving in this direction with this acceleration. So from the Newton's second law of motion, from Newton's second law of motion, we can write that resultant force is, here tension is greater than the frictional force, that's why it is moving in that direction. So tension force minus friction force. This is I'm writing left side, that is tension force minus Fk. Fk means mu k into n is equal to Fr, this is equal to m into a. Friction. According to the Newton's second law of motion, force F is equal to m into a. So then this is T minus mu k is 0.2 and n is m into g equal to, this is m is equal to here 2 kg into acceleration 0.2, already we got here. Okay, this is the acceleration produced in the 2 kg. So it is T minus 0.2 into m is 2 kg, this is g is 9.8, it is 0.4. Then T is equal to, this is we are taking to that side, that is 0.4 into 9.8 plus 0.4. After solving all these, we are getting here 3.92 newtons. This is the tension force. Then question C. The question C is, the distance the block would continue to move if after 2 seconds of motion the string should break. Okay, here when it is in the motion, horizontal motion, after some time this string is breaks. After breaks, then how much distance traveled by this 2 kg of mass in 2 seconds, that too in 2 seconds. Okay, for that we have to find out the distance. Okay, so then after falling it, after breaking this string, it is moving freely falling body, means it is moving like this down the direction. So that's why its initial velocity is equal to 0 and final velocity we don't know, but acceleration of this one already we got here, that is 0.2 meters per second square, and time already given, that is equal to 2 seconds. I think okay, once again I will tell you here. So this 2 kg of mass is moving in this direction while it is moving with the help of this m1, but after some time the string is break. If string is break, then it is moving freely falling. For freely falling body, initial velocity 0, final velocity we don't know, and acceleration already we got here. This is a is equal to 0.2 meters per second. After 2 seconds, while it is moving downward, uh, um, in 2 seconds how much distance it is traveled. So for that, here I am writing that we want to final velocity. So according to the kinematical equation, v is equal to u plus at. Okay, so that is v is equal to u is equal to 0 plus a is equal to 0.2 into time is 2 seconds, then v is equal to 0.4 meter per second. This is the final velocity, and we know that kinematical equation here. So before breaking, its kinetic energy is 0, that is initial kinetic energy is 0 and final kinetic energy is something is there, because u is equal to 0 means here kinetic energy 0. When it is reached to here, we have final kinetic energy. So here, so according to work energy theorem, according to work energy uh, theorem, delta k is equal to w. So according to that, here while it is moving in this direction, delta k initially it is 0 velocity, so that's why initial kinetic energy ki is equal to 0, and kf is equal to something is there. Okay, so that is I'm writing here, kf minus ki is equal to w. Ki minus ki, kf minus ki is equal to W. Then so kf is equal to half into m v square, and this is 0 is equal to W. Here W means it is moving in this direction, then work done by the frictional force. So that's why I'm writing here Fk force, and displacement is S. So from this, half into m v square is equal to mu k. So mu k is equal to, sorry, Fk is equal to mu k into n into S. Okay, from that mu k is equal to, so it is equal to mu k into n is equal to m into g into S. Okay, here half into m into v square, and here 1m cancel, and from that S is equal to so this mu k and g going to be here. So that's why v square by 2 into mu k into g. So S is equal to, v is equal to 0.4 into 0.4 square కాబట్టి. Then 2 into mu k is equal to 0.2 into g is 9.8. So 2 into 0.2, 0.4, these two and these two cancel. It is equal to 0.4 by 9.8, and that is equal to distance S is equal to 0.04 meters. It is our answer.